Hello, ma'am. Good morning. Can you hear us?
Yes, absolutely, Atin. So happy to see everyone.
Thank you so much, ma'am. I'll just take 2 minutes to kind of welcome everyone, and then the floor will be yours. So thank you so much. A very good morning and warm welcome to all of you to Anil Agarwal Environment Training Institute for this national conclave and release of report on our study that talks about methane emission from Indian dump sites. You all have the program, so I'll not go into the details of it. We have two keynote. In fact, we are supposed to be joined by Professor Sudhakar Yedla, but due to some family medical emergency, he couldn't make it till last evening. He kept on trying. So we have the Director General of CSC, Sunita ji. She has reached this morning to India from Sweden. She traveled, she flown all night, and she made it home just in time. And I feel kind of guilty because I practically forced her to be a part of this event. So, ma'am, we also are joined by Ashish Tiwari, sir, Secretary, Department of Environment, Forest and Climate Change. And we are also joined by Professor Shyam Asolekar, and I know for a fact that you know each other very well, so I don't even probably need to introduce you. Basically, if you just look at Swachh Bharat Mission, because everything that we are doing in this campus, in fact, there are constant capacity building programs being organized here for city officials, for civil society representatives, for industry, basically all the players in this ecosystem. So if you look at the Swachh Bharat Mission mandate from three broad points, the first one talks about biomining of the existing dump sites, which is very, very expensive and time consuming. So Government of India has committed massive financial devolution to support this activity and share the burden of the ULBs. The second objective is to divert 80% of existing solid waste from reaching the dump site, so that we not only process them for gainful economic advantage, but we don't allow another dump sites to be built. And then there's a deadline that we have to achieve this by 2026, right? So the context of this study was very clear. We wanted to understand methane is a potential energy source which we are wasting, we are losing. We currently do not have a scientific process of estimation in place. So Dr. Richa's report will talk everything, and she's going to make a presentation. So without wasting any further time, ma'am, if I may request you to address all the participants.
Thank you, Atin. Thank you so much for organizing this, and thank you, Richa, for your excellent study. Firstly, I want to apologize to everybody, particularly Mr. Tiwari and Shyam. I haven't met Shyam for so many years that I would have really given anything to be with you in ATI, to be there to discuss things with all the colleagues who are present. But please forgive me, I had a very urgent meeting in Gothenburg, Sweden, and I've just come back literally half an hour to join you, at least virtually. So, you know, when Atin and Richa and I discussed this study on methane in dump sites, what was very clear to me was that understand the opportunity that we have. We know that climate change is an existential threat. I don't think I need to explain that anymore to any audience, particularly not the audience in front of me. We know very clearly extreme weather events. Already when the world is only at 1.1 degree centigrade rise, 1.1 degree centigrade rise, and we are definitely going to breach 1 point. Really bad news. And we need to find every way to be able to combat emissions, to be able to reduce them. Now, CSC's entire work has been to demand climate justice, climate equity within the Framework Convention on Climate Change. But we have also, for countries like India, we need to look at where the co-benefits are. What can we do which is in our interest, which will also combat emissions GHG emissions. When it comes to dump sites, there's a clear case where we can argue that what we do in terms of reducing methane emissions becomes absolutely good for us, for our cities, for our health. Really is a good news story that we need to understand better and we need to explain to the world. Now, to do this, we need to understand, one, the science of methane. We need to know that methane is a short-lived, it's not a short-lived, but it's a shorter-lived, very potent greenhouse gas. We know that as far as methane is concerned, it's about 1/3, 1/3, 1/3. That's that the global sources of methane are 1/3 from oil and gas, 1/3 from agriculture, and 1/3 from waste. But I would argue with you that actually we have very poor estimation comes both from agriculture as well as from the waste sector. It's much easier, and even that is very weak in terms of estimating methane from the oil and gas sector. But as anyone will tell you, even those estimations are often off by a factor of 10. Now, given that, and given the fact that the methane reduction as an easy win, it's one of those which are called the low-hanging fruit, that, okay, we can't deal with carbon dioxide as much as we want. We cannot change our energy patterns as much as we want, but can we emissions that go into the atmosphere? At COP28 this year, methane will be one of the biggest issues that will be discussed. The Chinese and the American are expected to come up with a major meeting at COP28. We clearly need to know what are the opportunities. Now, this is where our study becomes very important. And I'm so glad that Shyam is there, and I'm glad that Mr. These are the two sides that we need to bring together. On one hand, there is the side of science that we need to estimate better. Richa has done a fantastic job in helping us to understand what is the state of estimation today, what are the gaps and the sheer differences in the studies that are showing in terms of methane estimation. Clearly, we need to work on that. We need to understand that better. Many of Anil was alive. One of our first studies that we had done was to look at methane emissions from cattle. And at that time, we had called it survival versus luxury emissions. But we had also argued that we really do not have what from Indian cattle versus cattle which comes from other parts of the world. Now, it may not be the same when it comes to waste. The characterization of waste is not that much different. But as Richa will explain from her when she did the study, there are many factors that influence the estimation of methane. And clearly those factors need data, because without data, you cannot make calculations. So thing that we need to work on, and that's one of the big areas. We need to work together. We need to understand better so that we have a more robust estimation, which can be used for the second part of our Tiwari comes in, which is really the management of dump sites. The good news is, and I think we need to talk about this globally, we need to talk much loudly about this globally. In fact, I have been asking Atin that we should organize at COP28 to talk about how this is one case in which the Indian government, under the Swachh Bharat mission, has made it very clear. In fact, the 2016 rules of the solid waste management, and very clear, we do not believe in landfills. Landfills for us are for the last residual fraction. And even that Today, the government of India, Mahua, is talking about a land, talking about how they can impose a tax so that there's a deterrence on city municipalities for taking waste to the landfill. Because waste is not waste in India. Waste is a resource. And this is comes in, because the more you segregate, the more you can do resource recovery. The more you can make sure that you can take your wet waste and reuse it. You can take your dry waste, at least the fractions of dry waste that can be reused, upcycled, and you can do that. And then only that which is absolutely residual fraction either goes into an incinerator or a landfill. Now that's government policy, and that's a very, very policy which the government of India has put into place, and many states are showing exactly how this is possible and can be done. There is another government policy brought in by Mahua on landfill remediation. It means that the landfills that exist, we need to make sure that those landfills are cleared. Now, as Atin very rightly said right at the beginning, and I think the tragedy will be, and I have seen that, Mr. Tiwari, and unfortunately one of the cities in Desh, which I know has now changed its practice, but I saw that and I've seen it also in Delhi, that on one hand, the landfill is being biomined and remediated. On the other hand, we're bringing in fresh waste into the landfill. Now that's public resources. Because the idea with the landfill remediation strategy is that we will clear the landfills. We will make sure that that land is then available for green spaces. We will add to the climate because the more we green areas, the more we deal with heat, the more we mitigate emissions. So it's a win-win story all around. We need now to understand how we can put this into practice at scale. Policy is there. We are beginning to act as well, but we need to make sure that the additional driver, which is that as we are remediating the landfills, we are also combating one of the of methane. That becomes part of our narrative. It becomes part of the driver of the change that we are bringing in. So I see this as a very, very important work that we are all in. There are many things that need to be done before we can scream about it, be proud about it, and talk about it, which is that we need the estimation clear, we need better science to be operated, and we need plans that are happening do not are working side by side with cities actually doing segregation, resource recovery, and then remediation of the existing landfill sites, so managing methane emissions. Combating methane emissions. I would love it if we could come up with a clear paper that says, with this strategy for landfill remediation, how much methane have we actually reduced? Powerful paper to put out. But for that, we all need to work together. So thank you very much, Atin. Thank you, Richard. Thank you, the full team. And thank you all colleagues who are in the room. I hope you have Anil Agarwal Environment Training Institute. And Shyam, as you knew Anil well, I hope you will agree that this is a good tribute to him.
Thank you. Thank you so much, ma'am. I just forgot to mention that we have a very diverse sector representatives right in this room. So we have people from research institutes, from academic students, faculty members, civil society representatives, industries, as well as many ULBs across the nation. And we are streaming it live in all social platforms. And Sukanya tells us that there is a huge number of participants who have joined us virtually. So, ma'am, I know that you have another event in Vigyan Bhavan, and Ashish sir also has to catch a flight. So I'm trying to balance both. So without wasting any further time, if I may request you to release the report from your end, and if I may request Solekar sir and Ashish sir to come here and release the report along with Sunita ji. Richard, why don't you just come over and you also. I'll do it. Ma'am, probably you can't see us because so if you have a copy, if you could just hold the copy.
I think Thomas was the copy. If you just hang on. I really you have to forgive me. Coming back I'll just get the copy. Just 1 minute.
Sure.
Thomas ne paper printed. You'll have to wait for 1 more minute, Atin. Sorry. It came very late at night and they put it in another room. Just 1 minute. Jaldi.
Sure, ma'am, we are waiting. No worries.
Sorry.
Thank you so much, ma'am. This is a unique photograph. I can show the photograph. So a bunch of people standing next to the big screen, and then you are one virtual participant with the report. I mean, we have done many releases virtually as well as physically, but this is a unique experience. So, ma'am, with your permission, I would like to take this agenda forward. And
Yes.
I know that Ashish sir has a flight to catch, which departs daily at 3 o'clock. So I would request Dr. Richard to quickly introduce Ashish sir, and then I would invite him for a quick keynote address. Over to you, Richard.
So I'll just try to be quick. So today we have Shri Ashish Tiwari with us. Shri Tiwari is currently serving as the Secretary, Environment, Forest and Climate Change Department, Government of Uttar Pradesh, Lucknow, Uttar Pradesh. Shri Tiwari has studied in IIT Delhi and Forest Research Institute, Dehradun, before joining the Indian Forest Service cadre of 1995 batch. Shri Tiwari brings more than 25 years of proven success spanning across policy and planning level in different capacity. To name a few, he has served as a Member Secretary, Uttar Pradesh State Pollution Control Board, Member Secretary, UP State Climate Change Authority, Member Secretary, Uttar Pradesh Environment Impact Assessment Authority, and various other positions under the government of Uttar Pradesh. There is a long list of accomplishment that he has, but please forgive me to keep it short so that we can hear it from him. Thank you so much. Over to you, sir.
Thank you, Richa, and very good morning to all. Very good morning to Sunita ji. And thanks for inviting me particularly to this beautiful campus. I had a very, very long morning walk, and it's really a pleasure that, and I heard the story that you yourself have planted so many trees over here. And the campus really tells the story of like it's the campus in the making, because I searched around the historical Google imageries also in the morning. So congratulations to you and everyone associated with it. And congratulations to Dr. Richa to have come out with such a wonderful report. And really it's a very pertinent issue of methane emissions from our dump sites. I always say about methane that it's a very, very silent kind of a polluter and very invisible too. When the question comes about the dump sites, we always feel that, and everybody has this feeling that there is a burning in the dump site, and maybe in the winters there is some air pollution due to that. But this report, of course, brings a different perspective that for the climate change, methane is a very, very potent, short-lived kind of a causative factor to the climate change, and the potency in a 20-year cycle is very, very high. So if we reduce our methane emissions, then very soon we will be going to see the positive impact on our climate actions. That is one thing. And second thing, the ground level ozone is also created by methane. So in a way, it's a kind of an air polluter also, apart from the burning of waste, etc. As rightly told by Sunita ji, that methane is responsible for around 30% of current rise in global temperature. And like the kind of waste our cities are generating, I was going through the report of Niti Aayog and Center for Science and Environment. Like the waste generation per capita varies from city to city. And there is a long range, and average comes around somewhere around 400 to 500 grams per capita. So in the years to come, I think the waste generation is going to multiply like anything, and we will be having more, like as Sunita ji was mentioning, that one side we are clearing our dump sites, and the other side the waste is again being dumped, and that will turn into a legacy waste. So those kinds of challenges are ahead of us, and in view of its like multiplicity of potency with respect to air pollution and global warming potential of methane, really a robust strategy needs to be designed. And I am happy that this workshop will come out with a blueprint of a robust strategy, that how particularly from dump sites these emissions can be reduced, and all kinds of efforts can be institutionalized so that the gap between policy and implementation is minimized. Working on the government sector, I always feel that the knowledge is everywhere. Like you can always very well say that this has to be done. But the question is how it has to be done. That remains a big question in our working in a country, developing country like India. And here is the scope where our research should come out from the corridors of research institutions to the policy level, policy makers, and appropriate policy is framed, and then an applied research has to happen that why that policy is not being delivered. In the morning, I was discussing with Agnihotri ji about waste to energy plants. There are so many issues why waste to energy plants are not being successful across the country. So now the need is to find out how best we can make successful models. Somebody will say some technical issues that our unsegregated waste or the Indian cities waste doesn't have that much of a calorific value. Somebody will say that. Somebody will say that there are issues related to business model. But to me, I think when we see the cross section of a country like Uttar Pradesh, which is, if it is being a country, then probably 6th largest country in the world, then we have, in the morning, I was discussing with a young boy that we have got over 750 urban local bodies in the state of Uttar Pradesh. And every urban local body, our vision is that it should have a material recovery facility. But how those facilities will be operating, how those facilities will be running and producing a good quality of RDF or segregation of waste, etc. That remains a challenge still when we talk of, if you want to reduce emission, the solution is very simple. Of course, very, very difficult to implement, but theoretically solution is very simple, that you have to have a better waste management. All waste management techniques are there, whether it is composting, that is also methane emission reduction friendly, whether it is waste to energy, whether it is bio-CNG, but the issues remain about its sustainability for the point of view of developing it as a business model. We have seen some successes, and there are opportunities also that new EPR regime, which has been notified by the ministry, how we can leverage that EPR regime for making a good business model out of waste management. We have done a very small experiment in the holy city of Prayagraj. There, the old dump site was being remediated, and in every city, in every UP city, you will find large dump sites. For instance, take the example of Lucknow. Lucknow has a dump site in Shivri, about 18 lakh tons of legacy waste, and every day 300 ton per day unsegregated waste is reaching to that site. The RDF which will come out of the remediation of legacy waste dump sites becomes a problem. Sometimes you will find that RDF is left over there just beside the dump site after the remediation. So we worked with Prayagraj Municipal Corporation and Dalmia Cement. The disadvantage with our state is when we explore the opportunities of co-processing, there is only one cement plant, that is Ultratech in Sonbhadra district, which is near to Prayagraj. Then the issue comes of transportation cost. So we had tried to make it a good business model by leveraging EPR notification, and the transportation cost has been shared by the cement plant under his own EPR compliances, because every cement plant has to comply on EPR also, because they also produce cement bags and all. And part of that, a consortium of brand owners, they shared the transportation cost. And I'm happy to tell you that Prayagraj, the waste has started going to Dalmia Cement, and now the Ultratech Cement has also developed a facility in our state also. They will be ready to receive RDF from many other things, but we struggled a lot when it came to the question of quality of RDF. To begin with, the RDF which our municipal corporation used to send to the cement plant was having inert material into it. The moisture content was too high. Then we made it clear that unless you give and there is a question of hand holding also. Then the ballistic separator was installed, and then slowly we did a good waste characterization study, and then slowly it got institutionalized, and a good quality RDF has started producing from Prayagraj. And now that pilot, which is successful, is now being implemented in Lucknow city. So what I mean to say by this example, that of course there is a knowledge, of course there is a way and means, but the question remains how to convert that knowledge into action. That is a big challenge, and I'm really looking forward to have such implementable models for methane emission management in our country, and particularly in our bigger cities of Uttar Pradesh. One it will have a great opportunities because all the states, including state of Uttar Pradesh, they are building capacities for waste management. Earlier, there was a gap, but thanks to judicial activism, thanks to the vision of the central government, state government under Swachh Bharat mission and all, like if I take example of UP, then we have around, of course, the waste generation data has to be again revisited, but we have around 15,000 ton per day of municipal solid waste being generated in the state of Uttar Pradesh. And now at this point of time, with best of our efforts, we have around 10,000 ton per day capacities in place. And in future also, our plan is to build up additional capacity of 7,000 ton per day by December 2023, and further scaling it up to 23,923 ton per day by March 2025. So what I mean to say that in a near vision, near timeline 2025 vision, the state will have excessive capacity than the waste generated. To the next 15-year timeline, at least capacity-wise, the state is sufficient to treat the waste. But the question will come that how this waste management will be taken care of, how the business model will be developed. So for methane emissions also, of course, there are some errors, there may be some underestimation about the methane emission, but that doesn't stop us to start our actions at this level. So I would be rather more interested in looking forward to a business model wherein we can really come up with public-private partnerships, because now we have a land, we have a waste processing facility, and now if we can institutionalize the methane emissions factors also in our PPP model and develop a good business model, like take example of China, the value of waste to energy in China, for the value for every unit of electricity generated out of waste to energy plant, it has doubled in a period of say 6 to 7 years because of stringent air pollution control norms. Because air pollution control also has a cost. So really waste to energy plants, air pollution is a big challenge. So state-of-art air pollution control systems, we will have to look into that. What are the investments? What are the returns? What government can put in as a part of financial resource into it, and how it can become a good business model. If we really work on these lines, then probably we would be winning the battle of waste management and in turn the methane emissions in our country. So much has been done about different methane emissions techniques, and there are now the methane emission monitoring sensors also in place. But we would be really very happy, and where I would request Sunita ji also to develop a system like many cities are going forward for hiring vendors for waste management under different kind of models. How we can build in the methane emission strategies into our RFPs, etc., that would be like very helpful. So that could really be a value addition, immediate value addition to the methane emission management. At the last, I would say that whatever we talk here, we must come out with some kind of a pilot which is successful, so that really the urban local bodies and other actors and players also, they can really understand that it really makes a good business proposition to make any investment. Yesterday, I was mentioning with one of my friends about a small paper and pulp industries in Muzaffarnagar. So that industry was non-complying and Honorable NGT had sent us to visit and inspect that industry. When I was owner of that industry was a young boy, I was just trying to know from him that why he's not operating his water treatment systems in the industry. So very plain and simple, he told me that if I run the effluent treatment plant, then my business will not be viable because there is a cost to it. So we really should think that at what is scale our operations, our intervention should be. Whether they are profitable at a small scale, whether they are profitable at medium scale, whether they are profitable at large scale. Indore has given us a kind of lesson that if we go for waste to energy on a larger scale, then it would be successful. If we go on a small scale, decentralized way, then probably it may not be successful. It may be otherwise, but what I am trying to say that whatever kind of strategy interventions we have, really we should have a very, very robust cost benefit analysis so that any investment which comes in that particular sector really makes a good successful business proposition and in turn a good successful waste management infrastructure. So with these words, I extend my heartfelt thanks to Center for Science and Environment. And I have gone through, and thanks to Atin who have shared with me this report in advance. I have gone through it. It's a very good report. I would be looking forward to also know, I would really love to have attended this workshop for both the days, but Richa has promised me that she will share the blueprint of discussions of this workshop. And we assure you, Sunita ji, whatever good findings will be given to us, we'll try and make it a good policy intervention, and we'll try to institutionalize it. Thank you so much.
Thank you, Tiwari ji.
Thank you, sir. Thank you, ma'am. Let me now invite the last keynote speaker before we move on with the technical sessions. Professor Syam Asolekar. Asolekar sir is kind of an institution in himself. He has been teaching in IIT Bombay for more than 30 years. So I'd request Dr. Richa to quickly introduce Professor Asolekar, and then the floor is yours.
I feel honored to introduce the next keynote speaker, who is also my PhD guide, who was my PhD guide, but mentor for life. We have with us Professor Syam Asolekar, who is currently serving as a professor in the Environmental Science and Engineering Department at the Indian Institute of Technology, Bombay. Earlier, he has served as the MPCB Chair Professor at IIT Bombay. He has also served as a head of the department during May 2006 to 2009, and the president of Indian Environmental Association during 2003-2005 term. Since 1997, Professor Asolekar has been the member of the Hanu Taluka Environmental Protection Authority, which is constituted by the Honorable Supreme Court of India and entrusted with the biodiversity conservation and sustainable development of eco-fragile region of the Hanu Taluka in Palghar district, state of Maharashtra. Recently, IIT Bombay honored Professor Asolekar with the prestigious Professor S.P. Sukhatme Award for Excellence in Teaching for the year 2020. Earlier, he has received a Dr. P.K. Patwardhan Technology Development Award from IIT Bombay for development of innovative environmental technology. In 1994, he was the recipient of a Rockefeller Foundation Fellowship for Leadership in Environment and Development for 2 years, Professor Sulekar has also been the recipient of the award for outstanding PhD thesis given by the American Chemical Society in 1991 for his doctoral research in environmental engineering at the University of Iowa in USA. Professor Sulekar holds an undergraduate degree from Institute of Chemical Technology, formerly UD City, Mumbai, and master's degree from Indian Institute of Science, Bengaluru. Subsequently, he went to US to obtain his MS and PhD in environmental engineering from Syracuse University and University of Iowa, respectively. After pursuing his postdoctoral studies at Harvard University in Boston, he returned to India in December 1992 to teach at IIT Bombay. We are so glad to have you here, sir. Over to you.
Yeah. Wonderful. How much time do you give me, Richa? Okay, I'll stop after half an hour. Yeah. Yeah. That's just. ये रेखा था, ऐसा तो नहीं हुआ ये उसके बाद लगाया इसलिए उसको बाहर जाके निकालना पड़ेगा। ठीक है, इसको क्लोज करो, फिर से एक बार शुरू करो। नो इश्यूज। So I will not use it now. Yeah. Okay, my time starts now. Director General of CSE, Honorable Sunita Narayan, Shri Atin Biswas, Project Director of CSE, Dr. Richa Singh, author of the report and also the scientist working with CSE, Honorable Secretary UP Government, Secretary of Environment, Forest and Climate Change, Shri Ashish Trivedi, my friend Dr. Sunil Kumar from CSIR Niri Nagpur, another friend Dr. Agnihotri sitting in the audience who did excellent work in ONGC and one of its kind work in the methane gas extraction from landfill in Lucknow. Extremely good learning came for this country because of Dr. Agnihotri's work, and rest of the important people, unfortunately, I do not know personally. A lot of young people from CSE and friends. This is a lifetime opportunity for me to come back to Sunita Narayan's Institute. Always I refer to it as to give a presentation. People call her with many, many big names. I call her Sunita Narayan. That is the name I learned when I was a student. From so many years it is going on. And I didn't have fortune of working with Professor Agarwal. Just saw him once talking to somebody who was working with him on one of the very early state of environment reports. It must have been 1978, 79, something like that. One of the probably first, second kind of report. So it feels great actually. My blood pressure changes when I sit in front of people who do not need oxygen to breathe. They can do well with methane. So such audience is not there to be found. And people who would like to address the issue of methane is a great thing. And very proud to be associated with this event. There are many things in the syllabus which cannot be completed in one short lecture of half an hour. Come to IIT, I'll teach you 2 courses so that you will get the glimpse of what exactly entangled issues of science and engineering related to the landfill management, and then concurrent issues, the similar story unfolding in the field of hazardous waste management, in the field of biomedical waste management, so on and so forth. Biomass, what to do with biomass is a big issue. People in Delhi always blame parali burning in happening in Haryana and Punjab, but it's a much, much larger issue than just talking about parali. So there are many issues that are part of the larger discussion. So the topic that is assigned to me by Richa is from trash to treasure. Indeed, as Sunita ji said, it is a treasure. It is not a waste. It is waste until we understood what to do with it. So how do we really embrace the approaches related to circular economy? Can somebody make it go? This thing? Is it something that I'm not doing well, that I'm missing the top line of my, this is remaining all the way?
I just
Yeah.
right.
I have no difficulty in accepting from my handphone to PC, they are smarter than me. So it is a big issue, yes. So there are 2-3 themes that I'm going to basically talk about, and then I will probably go like a Punjab mail. Forgive me. I have already handed over my presentation to Richa, who can send it to you or put it on whatever is the policy of the institute or whatever the collected works coming out of this particular symposium. So 2 basic themes that I'm going to talk about is the issues related to different kinds of biomass. What can we do? Which may appear to be a subset of the solid waste management problem, but quite contrary, if you look at the quantities and the locations of creation and the reasons because of which they are created, if you really analyze it with a cool heart, you will really understand that it is, in fact, the solid waste management or municipal solid waste management is a subset of the larger issue. But surprisingly, and the saving grace is that the solutions, those are associated with these 2 groups, are comparable and in many ways identical. In fact, if you get positive experience with one, you will win with the other. It is so simple and straightforward. It is simply the matter of doing it. It is not going to move Chandrayaan 4 that we need for that. We need to actually understand and do it something by our own hands at wherever location that we are situated in. Limited experiences there of the valorization of paddy straw. Paddy straw is one topic that I'm talking about because a lot of humdrum and lot of discussion is about the smoke in Delhi. And we always think that farmers are uneducated, they know nothing. and they burn paddy straw, and it is absolutely a criminal activity. The feelings are understandable, but they are simply stemming from over emotional analysis of the topic rather than slightly intellectual and management oriented analysis. No valorization of waste biomass from the generated from natural treatment. Natural treatment systems are because of your efforts, such as constructed wetland, in which I have sunk my 18 years of my career. But it is happening anyway when you don't attend to the water quality in a village pond. You are having natural treatment system taking over by nature, and all the hydroponic species there, they will be generated, they will rot in the same water pond again, pour methane, put it out, and develop some kind of very calcitrant biomass, which will settle at the bottom. Sinking will take place, and one day village will have to spend 20 lakh rupees from their coffer to clean that pond, so that the wastewater of the pond, city or village can be put in that, which again will feed into generation of methane. So it is a vicious cycle that barely anybody has understood. And I'm only bringing to this august audience that beyond what report has been written by CSE and Richa, there is a big world related to methane, which we need to integrate with the problem of methane in a larger sense, which in fact is a worry of, for example, Sunita ji. She was talking about global climate change, and she was talking about the role of methane, and the Honorable Secretary was mentioning how much is the contribution of methane to the global climate change story. So it is important for us to understand that methane is not the only ghost that is coming out of solid waste dump site, but there are many other places which is prominently coming out, and we need to be equally intelligent and mindful about managing those problems. Limited efforts also are there with respect to STP in the sludge, and I do not know, and it is not, I'm not making any slant comment to anybody, much less to any city administrator. One or two new acquaintances are sitting in front of me, but I'm not making any slant at them. But there are many places, and I only have limited experience of Mumbai and some of the small places that I worked with in Maharashtra. Rest of the country I do not understand, but they are separating sludge very effectively from whatever primary or whatever half-done secondary treatment, but then they're sending the sludge independently to the ocean, because there is no other place to put it into, and that half-treated wastewater is put into ocean. So you probably, one can make a black humor that why are you doing all that, throw directly the raw wastewater into ocean, but you cannot belittle them and take away whatever little credit that they can get. But that is the story. So we need to understand that we need to be more mindful about even the huge quantities of sludges. If at all one day India treats all its solid waste, all its wastewater, then you would realize that it had created a new ghost of municipal sludges coming out of wastewater treatment plant, which are typically called as STP, sewage treatment plant. No sewage is a pure sewage. It is not an academic joke. It is a fact. No sewage is a pure sewage. It is always mixed with some kind of industrial sewage, industrial wastewater, which is coming from very small scale and tiny scale and kitchen scale industries, including a photo shop, including a photo developer, including a medical lab and things like that. So nothing is only domestic sewage. It is also so many other industrial activities mixed together, biomedical activities mixed together. So it's a very complex entity, and what to do with those sludges is not a simple question. I will not say it is $1 million question, because $1 million is nothing if you really want to address that question. So it is trillion, billion dollar question for India. If a city like Mumbai literally brings a river of drinking water, literally treats that river of drinking water for peoples of Mumbai, only services 50% of people in Mumbai. The remaining water is not there. Other people make do with 20 liters of water per day, while rest of the Mumbaikars are enjoying 165 liters per day. So water is not only a common good, it is a social good. It directly enters into the front door entry of social justice, equity, accessibility, and the people who are affected most when you do not address the story of water properly. The most that part of the society is the gender which balances 50% of the which holds the 50% of the sky. So I'm talking about women. They are at the receiving end, the worst receiving end, when you do not address the issues of water. That is a direct entry to generation of methane. That is a direct entry to generation of sludges. That is a direct entry to mixing pathogens with some of these entities which otherwise did not have any pathogens. So you should try to combine a larger picture and understand a larger story, which is evolving, unfolding parallelly parallel to the landfill story. Lack of priority framework in India for policy framework for India and setting up a priority for managing and disposal of so many waste biomasses is also another issue where directly agriculture comes. People may be very much in hurry to declare that India is highly urbanized, and people imagine that 60-70% people live in cities, contrary to the fact that not more than 45% people are urbanized. Remaining 55% India is rural. 55% of 144 crore, you can figure out, is a very, very large population, which is of the order of 80 crore, which is a very large population. And they are engaged in activity known as agriculture, which may be criminalized in many ways by people because of their half understanding. But you cannot eat polypropylene grain manufactured by the largest manufacturer of the country or the world. That is not enough for you. You cannot eat polypropylene. You have to eat grains. So you cannot belittle that sector that brings the give highest job to the people. Most of the landless people, most of the people who are earning bread is because of that sector. And we cannot really overlook that. That sector is responsible for biomass. So therefore, doing something gainfully with biomass is also empowering those. So if you really want to empower women, Atin, I'm telling you something very important here, that if you empower women, want to empower women, addressing biomass issue of the villages can be a potion, can be a medicine. So there are much larger issues that are associated with methane, and I'm glad that I'm getting an opportunity to display those issues in front of you. But anyway, everything cannot be said in one lecture. So we will go forward, and I'm stuck. Is there a conspiracy here? No. Now technical side is coming, so I thought that you were saying that, now I will.
Something is wrong. Maybe I can just use this.
You ask Richa, nothing is wrong with computer, there is something wrong with me, maybe I'm not pressing it well. Yes, so it is working. Yes. So I'm just going to talk very quickly about a most recent, the ink is wet. This work is of Shruti Sharma. She is my PhD student who is closing her thesis in a 15 days period. And this is absolutely the wetting that you are seeing. I have just understood it completely recently and then helping her complete her thesis. There are many objectives in her work. Some of the objectives that are directly pertinent to your topic are displayed here. To display, to develop the natural fiber reinforced polymer composites. Those natural fibers are actually coming from the wastewater treatment using constructed wetland. And if you use the nature-based solutions, which are classically called as natural treatment system for treating the wastewater, if you really take those, then huge amount of biomass is generated in the country. Even if you argue that only 50% of the wastewater is treated by natural treatment system, which will grow now, having secretary like Mr. Tiwari, things will grow now in the direction of natural treatment system. And you will have more biomass coming out. Today, the biomass rots in the same system. Therefore, the system creates methane more than treating the wastewater. So that is the long and short of the story. And many institutions are working in the country on this particular topic. I'm not the only one, but I have some experience in that. And that biomass story is covered by Shruti Sharma. So we are trying to characterize, for example, two biomass we address. One is paddy and one is from constructed wetland. And we try to kind of develop the various composites using by separating the fiber. And there is a lot of scientific discussion that can be made on that. And there would be a different opportunity for some of you who might relish more technical discussion on it. But basically, we have used polypropylene binder because polypropylene is available rather very easily because of COVID pandemic. Polypropylene was the material that was used for all the apparels and all the protective gowns. So that separated from that was the source, that is from municipal solid waste again. And then we use that, and then that is replacing the phenol formaldehyde, which is a known carcinogen in making the composites. So that is basically the long and short of it. Technical details can be read in her papers. She is publishing lots of papers, so I can even send you anybody all the relevant literature. We are not the only people in the world who is doing it. There are many, many better people than us who are doing it. But we are the people who are concentrating on the story of solid waste, story of municipality, story of pandemic, and how it can be related to gainfully converting into the industrial application. We are transferring technology to industry to practice it and to sell the products, and using the natural fiber, which is also incorporating the biomass, to study the potential of developing these natural fiber composites, and the similar effort like Parali was also with the constructed wetland biomass. And again, similar kind of findings are there. There are the applications are different of the polymers that generated from constructed wetland polymer have particular property. So it can go in slightly value-added products, like making of the casings of the mobile or fender of the car and things like that. But the other biomass, which is Parali based, there are silica and calcium contents are different of these two vegetation. So accordingly, the applications also vary. In fact, now there is also a research that we are starting how to get silica from the paddy straw, and how that can become a source of silica for the Silicon Valley applications. So those are the tentacles which are coming out of, because we are studying various components of this problem. And I'm not going to get into again the scientific methodology to study the conversion of linear cellulosic wastes generated from the constructed wetland and converting them into different kind of biochar. Biochar is nothing but a koila, just kind of black powder that is generated. What is called as biochar, what is not, there is a very big scientific test for it. And what we have found is a biochar. You can simply take it and take a ghamela and burn it. You will get some kind of ash that may not be biochar. So you need to burn it in a controlled oxygen condition so that some of the carbon remains in it. That carbon has to be more calcitrant in nature so that it is not bioavailable for plant, so that it remains as carbon. Otherwise, plants will eat them up. So there are many conditions, but there may be some organics that may be volatile organics that may be associated with them. What is the role of them, whether they are an impediment, in what situation they are. It is a matter of more scientific discussion, which we can make later on if and when we have opportunity. So slow pyrolysis is done. The high pH value of biochar may act as a liming agent. Always otherwise there are liming costs. So when you use biochar as a soil conditioning agent, the liming costs are saved. I am lying to you through my teeth because lime has another environmental and soil ecology advantages which biochar doesn't offer. So don't believe 100% what I'm telling you. Only 50% you believe, because 50% truth is not known to me. So there are many other entangled issues with it, which we need to do for more scientific analysis. Somebody doing something in laboratory is a good reason for him or her to get excited, not for practical people who would like to put it in nature. We need to be more responsible and more knowledgeable. And it is an important disclaimer coming from a professor. So, so pyrolysis is a very good opportunity, which gives many types of powders, gases, which have different kind of applications. They even give nanotubes, carbon nanotubes, which have very great application. Separation costs are humongous. What to do with unused nanoparticles is another environmental toxicological story, which is yet unfolding. So there are many issues with it. I'm sorry, I don't have single answer for everything. There is no single answer for everything, you know that. Another class of problems that were addressed by Richa Singh of CSE. She was a PhD student in IIT Bombay, and she addressed basically two kinds of problems. And when I say she, along with her about 20 master students, so it's a big team that works always with its ecosystem. Again, one PhD student supports 10-20 master student. Richa took probably longer time to finish PhD, so she supported more master students research. But the bad side is took long, more years. Good side is produced very high quality work. And you have the high toxicity, low volume waste is one class. Low toxicity, high volume waste is another task. And the problem is not seen generally by the practitioner the way I'm putting it. But this is the way we academicians try to even classify the problems. Not only solving a problem is a contribution, classifying the problem also is a contribution. So therefore, we have classified them in such a way. And for example, the low volume waste, for example, can be fly ash. It can be so many other industrial solid waste, which are not of having toxicity, much significant toxicity. And the opposite can be the hazardous waste. You have to develop a sustainable binder for solidification and stabilization for asbestos, for example, the low volume, high toxicity waste, maybe asbestos containing waste. So binder for that, and also for other hazardous waste generated by the chemical industries and refineries. And basically, we are trying to convert that into some shape that can be molded. Mold can be of any shape. The shape is not a discussion topic here. The recipe, the methodology of developing a geopolymer is the basic argument that we are making. It's a very lightweight product that you get. Cement product becomes very heavy. It's a very lightweight. The strengths are even better than the stipulated for industrial application. So you can play with the recipe, and Richard did super brilliant job on that. And then we know if you want to make a weaker product, she can make it. If you want a stronger product, she can make it. And then we tested it by some 20 ways, and weathering tests, and how hot and cold, and thawing, and very high temperature, and vibration, and compression, all sorts of tests we did, cyclic loads. And then we came to conclusion that this indeed is a product that can become a product to transfer to the practical application. Characterization of legacy waste is another thing on which she spent her efforts. And it was a pioneering effort done by my group. Even before the word legacy waste was thought about, imagined, articulated, our work was nearly done on the Piranha dump site. And they were going to do the capping of dump site of Piranha at a cost of, if I remember well, it was something like 180 crore. One may argue that 180 crore is nothing for a municipal corporation. That they may be right, and I wish they are right. But if it is not right, then the whole thing can be done in 40 crore, and more meaningfully, more responsibly, and you can take every component of it. Unless you are Einstein, you cannot vanish the solid material, but you can definitely put back into another cycle of gainful application, which we try to do. And whatever resulting waste that comes out is going to be so small, it is going to be something of the order of 5-10% of the whole mountain. So converting 100% problem in 10% problem, making some profit on the way, and then being responsible and getting a good night's sleep because of that is yet another benefit that you can get if you manage legacy waste. There are many places nowadays legacy waste has been addressed. Many municipal councils and corporations have successfully done it. Some of the case studies CSE has published already in their earlier publication on case studies on the legacy waste management. Good work has been done. And then I have just experience with Piranha, and now a little bit in Mumbai. But there are many, maybe 30-40 places, and Richa can correct me more how many exact, Atin knows how many exact are there. But they are there of the order of 3-4 dozen, and everybody has experience. One thing just I would like to add to that, which is, congratulations to the people who worked on that. It is a good thing. CSE has published very scholarly work on that, and the approach that is used in CSC's publication are analogous to what we used in research about how to really look at the generation potential, the composition, the airwise generation, and things like that. So that approach is available with us in the form of experience, and a huge amount of literature is there in terms of not only the technology, science and technology, but also the management, how to really do things. And then we developed, we talked about making different kind of applications of the inert that come out. And Mr. Tiwari was saying about the moisture content, organic content, and things like that. So which layer of the legacy waste to be converted in what kind of application is again $1 million question. And that has to be done with more responsibility and good scientific understanding. So obviously what you were saying is right. So the basic question is essentially for us in terms of the topic of today's symposium, that is how do we use the circular economy and manage the solid waste in the country? How much is it? Where it is? What can we do about it? Which I call as there are two clear problems, again, very clearly and very scholarly way explained by Richa in her PhD dissertation. The hind casting of the problem and the forecasting of the problem. We always know that we are standing here and we understand little bit about what we understand about today. With that little understanding, can you really try to explain the past so that I will have little bit of confidence that you are going to predict what is going to happen in future. So hindcasting is a very important intellectual process that every researcher has to go through if he or she has an ambition of applying the knowledge in real world. Doing in laboratory needs immense intelligence and effort, but even more creativity and innovation is required if you want to take it to the real field. And that is where we spend huge amount of effort, about 30–40% of her PhD thesis and many master students working with me, we spent energy on to hindcast the estimation of legacy waste. When legacy waste was not accepted by Central Pollution Control Board as a terminology, we had already estimated how much was the legacy waste in India at that time. But then later on, we realized that we were primitive and we perfected that model, and very sophisticated model has been put by Richa in her PhD work. So basically, the problem starts with knowing the demography, and then you know that the population is going increasing, and you know you only have the red spot and the green spot, or blue spot. Those are the only data you know today. And World Bank and Asia Development Bank and blah blah, and so many business councils will come up with their own data. None is really doing the demographic analysis and population forecasting. We did it. Not because we are experts in that, but we understand mathematical models. We know how to handle large data set. We know how to do forecasting and hindcasting. So therefore, we worked on that. And this is the result of our model, that we are dot on money, and anybody can come and check with us on how to predict the populations in future and how to go in past. So we have done that, and based on that, we have now separated the story of rural India and urban India, which is rare, non-existent anywhere. I can go on record and tell you. Nobody can really tell you how much is the population of rural India. And then once you have a little bit of knowledge, your ego goes up. So then we also wanted to predict it for the future. And we went all the way to future. But more important thing here I'm showing you is that we were not sure what are the factors that are influencing generation of solid waste in past. Today, in particular area, because of the economic and the earning ability of the population, you can say in a moneyed class, this is what happens. In Jhoprapatti, this is what happens. But how do you really apply that to a state like Maharashtra? How do you apply to all states in India? And how do you say anything about India? So that is a very complicated question. And we try to spend too much of energy on trying to understand the variability. And then we try to kind of constitute scenarios that so much percentage is biodegradable, so much percentage is not biodegradable, which is in a way a proxy for the economic activity and the things people buy and consume. So using that as a footprint, we try to do the analysis. And then we have come up with the hindcasting of urban legacy waste and hindcasting of rural legacy waste. You can say that whatever you do in terms of the assumption, the changes are not dramatic. But if you really take the vertical slice of the graph, you will see the net numbers are very large. And your investment can go 50% wrong to 150% wrong if you really don't understand these differences. They may look very simple on the graph. Anyways, so we did the hindcasting and forecasting, and then we tried to go for the compositions and the capital expenditure share of it. And then we also did it for the processing cost and how much will be the revenue. And once we have done the hindcasting, then we applied that also to the forecasting and what can happen in future. And then we try to also build our scenarios in the sense that if I do so much, what will happen? On the left-hand side, the orange graph is if you do nothing, business as usual. Then if you try to do something, the top is business, the one scenario, and the bottom is another scenario, where if you do more of the tweaking management intervention, then what kind of reduction of problem can happen and how that will also reflect. But mind you, even to do intervention, you need to invest money. That those monies are considered. To get that money, you need to go in money market, understand the financing, and the give for that. And also depreciation is there. Nothing is permanent. So every set of equipment, moving equipment, will have a lifetime of 8 years. The stationary infrastructure will have a lifetime of 15 years. And then there is money market issue. So all that is taken into consideration in our business model calculation. It is not the best of the best like a trained CA or a economic scientist in the World Bank or Reserve Bank will do it. But it is almost considering all those considerations because some of those people are friends. So we have taken the help and we have done something, if not the best of the best, but not 3 best, but 1 best job we have done. And we have some kind of idea that 2021 money is known to us, how much it is. Now, 2021 and 2023 are different money markets, you know, today. So after COVID, everything changed. But even there are better experts than me who can even convert our numbers of 2020 to 2023. There are better ways. I never imagined COVID in my analysis. So you have the business model for circular economy, and then we have all sorts of things. This a variant of that Risha has published in the book that he has published. She has published earlier on legacy waste management. A better picture is available there. If you have access to that book, please read it. And then there are various types of gainful applications, which are again depending on ability to develop markets. So a lot of policy, a lot of handholding, as Atin says that, you know, all that help has to be there from government. You can't, you know, be very egotist and say, I'll do everything by myself. One NGO, one professor of IIT cannot do everything. A lot of government intervention are required, and we are mindful of that. And I do not want to now, the time is almost up, so I'm not going to give you more details. But, you know, I feel sorry that I'm not able to give you more discussion on this, but there will be always next opportunity. I always bank on that. And then there are 2 models. That one is business as usual on left-hand side. And if you do interventions, the graph has come much lower, you can say. But no matter what, it will increase. And the numbers are very high. But 2050 story of the intervention that we have suggested in B, that highest number is much lower. It is 10.5. That the number is already 12.25 if you don't do that. And then that 12.25 and 10.5 is a huge investment that if you really want to talk about, and the creation period can be anywhere up to 8 years, from 4 years to 8 years. So it's a big management challenge. It's a 3-dimensional problem. It is not only 1-dimensional. Similarly, the urban and rural differences we have given, the best part of our work is we are distinguishing the story between urban and rural. The other best part of the thing is that we are the first people who very clearly state that never create too many landfills, but you create one centralized facility where incineration and landfilling will be done together, and then you will transfer some of the things into the landfill, which you are helpless about. Very important thing, especially for the people who are from city administration. You should pay attention that there is a turquoise blue. Turquoise blue is the surplus. You guys are not supposed to make profit in legal language, but you should make surplus so that it can be transferred to some useful activity like women empowerment, child welfare, primary education. You better do that. And to be able to do that, you need to minimize the cost on environmental infrastructure and environmental implementation. So you can make surplus if you work intelligently. So I have no idea among the 40 case studies that Risha has reported in our earlier book. Atin, I'm not sure how many people have really made it with the turquoise blue line in the mind. I am not sure. But we did it on paper and our numbers are credible because we checked it with n number of experts. Nearly all the people, when we did it, I knew them personally and we checked with them, and it is not based on imaginary number. That much I can tell you for sure. Today you split hair vertically, maybe you will do better analysis, but analysis can be totally out of graph. You can't increase the slope of that blue line, or you cannot make it very much up or very much down until you bring such a private player who is reserving 50% profit in his business model. If you bring such a person, which are replic today in the market, if you do that, I'm sorry, then you will not make any profit for country. Somebody else will make profit. Chalo, that is also a starting point, I think, that things are possible to do. But today, I'm not sure how much of the remediation is with that. But again, I'm just a professor. My knowledge is very limited, and I've cooked up in my lab. So how much can I know? So you can disregard what I have said. So you have a story which is a combination of urban, peri-urban, and rural economics, rural application of technology, and rural management. And now you know that transportation is 82%. That is where decentralized solutions, Atin, that is where intelligent technology, that is where higher science and technology, that is where role of NIRI, IIT Bombay, and so many the regional engineering colleges, national institutes of technology, the places for higher study and research is there. That you need to minimize the quantity, otherwise, and you need to do it decentrally in a very intelligent manner. For example, this lecture can be 6 hours. I will finish it in 6 minutes. Now, too many things can be said, I think. But most important thing that you should understand is that you cannot think that anything and everything works everywhere. One size fits all, or anybody can do. No, don't say no to anything. Kuch bhi kar sakta hu. This confidence is okay in management books. But when it comes to environment, it has to be extremely responsible stand. Certain things cannot be done in small scale. Even the instrumentation required to do environment safeguard, you are not competent. You are not capable of maintaining those instruments. So incineration should be done at large scale, largest possible scale. One incinerator per state is a dream, but maybe it is a foolish dream, because Maharashtra, Gujarat, like states, West Bengal, Uttar Pradesh are very large states. Even divided Uttar Pradesh is a large state. So probably you'll have to think of 2-3 focuses where this activity will happen. Even solid waste management regional facility, Mr. Dilip Kumar Madhavan was telling me, I don't know where he's sitting, he was telling me that he is doing in the 3 places in Kerala. Only one question I asked him while having breakfast. Breakfast was very good. I was enjoying breakfast, but only when I saw him, I asked one question: how many landfills? 3. I'm happy. I did not ask anything more, because if you try to do one, again, this yellow portion will be larger. If you try to do too many, 20 places, every enthusiastic municipality wants to do it, then the other places, other things are more cost, which are environmental damage. So you need to really balance that. So this yellow thing is important, which is directly dependent on smartness, not on the smartness and the degrees of the administrator or bureaucrat. They are directly product of the technology. But we need to really develop those technologies, test them. Don't tell me in Switzerland it works. I do not want to say remaining half sentence. I want to have my own technology. It is tried in my country, done by my people, so that I don't have to wait for Switzerland to send me a motor that I can buy from Kirloskar or Cummins, which I can buy for 16,000 rupees. They will charge me cool 86,000 rupees. And you will simply make a mistake of asking me which and when. You will laugh. It is a reality. That's what people are doing. They are making business on spare part when they sell you technology. So please, try to be more intelligent and more responsible. There are many things I can bring to you, but maybe on a later date. And again, there is a story for rural area now, that how the benefit can be there for urban versus rural, with interventions, without interventions. Well, so there is a story for rural India and there is a story for urban India, but the conclusion is same. You need to apply technology. You need to combine very judiciously centralized and decentralized technology. Many of the things that you do in rural areas, which are of the order of 400,000, 4 lakh to 5 lakh locations are there in our country. You can cluster them 20, 30 locations there. One Chota Hathi, which preferably powered by solar or some kind of bio-CNG. You can use that to make transportation, have a 20, 30 cluster in rural areas. Such 20 clusters can feed into a larger place where further value addition can be done. And then finally, they will feed into some place in Pune, some place in Nagpur, some place in Kottayam, some place in Kochi, that kind of things you can do in rural, in the regional area. And then you can solve the problem where further incineration, further value addition, burning kachra looks glorious. You can print glossy reports, Atin, by burning kachra. But then rest of the things people are breathing in the city, it is the lowest on the rung of thermodynamics, which even engineers don't want to understand. You understand it, therefore I'm mentioning it to you, that thermodynamically speaking, all the shiny base technologies get the healthy degrade from me. They are not actually viable technologies in long range. Nobody should do while making a lot of talk about sustainability, should not be taking those kind of technological alternatives. So I will basically just go into the last bit that I want to make you. We cannot see the problem of solid waste management or methane or any such issues, which are partly global and partly local issues, from only the point of view of that waste management story. But it is a large part of a larger democracy story of our country. And please understand, the people who are involved in managing that kachra, the people who are involved in doing oos todni, the ganna workers, or a lot of farm workers, which are the landless labor, many of them are women, many of them are under 18 children. Their rights, their future, all these issues are on the table if you do not manage the solid waste story properly, if you do not manage the wastewater story properly. And then on top of it, the side story that you are wasting that resource, which otherwise can come into a more gainful application. So Swatantra, Samata, Bandhuta, and Nyay, these four principles, which are the four pillars of India's constitution, are not the words left to Dr. Babasaheb Ambedkar to write in constitution, but they are really the cardinal principles for us to live life, which is very important for us to understand. Everyone here knows what is Article 21. I'm just only going to tell you a twist in the story when you talk about Article 21. It is popularly called as fundamental right, the article which is about fundamental right, every article about right to live. And you know that the basic constitutional literature as created by the creators of the Ghatna Assembly, the Constitutional Assembly, the basic constitution created by them is essentially a bundle of fundamental rights of citizens. There was not one fundamental duty put in it. Hear me carefully. Not one fundamental duty put in it. Only fundamental rights and then directive principle given to the state. So that is what basically it was a bunch of principles. And it basically says verbatim, Article 21, no person shall be deprived of his life. When they say his, it is biblical, his means her. That distinction is not there. So Richa should not tell me that why her is not there. So no person shall be deprived of his life or personal liberty except according to procedures established by law. The second half is a disclaimer of the government. We can put you in jail, we can curtail your rights, but which is correct. They have the right because they do benevolent things. So they have full right to do that. It is the job of the government in democratic country. So popularly quoted, this is article of right to live. Philosophically, it is expected that to be implemented, it should be implemented as right, live and let live. So your right to live, you should be extremely mindful while living that you must make other people live. Create conditions. In the tradition of free India, any manifestation shorter than the acknowledgement of others' right to live would be deemed uncultured behavior. It cannot be upheld or justified. We in India never approve that. So we always believe in live and let live. And you don't need to give any praman, any proof from Vedas, Upanishad, which I very much like to understand, but it is right there in your constitution. Please understand. Article 21, Honorable Supreme Court of India and others, almost all high courts in the country have interpreted in favor of environmental protection. And you would wonder why that leap of imagination. And that's what I'm trying to explain to you, the twist in the story. I understand only mathematical equations because that is what the limited thinking I have. Right to live is equal to right to live in clean environment. That was a very clear verdict of the Supreme Court. When you say right to live is equal to right to clean environment, obviously the next argument is right to live is equal to right to healthily living. So that is a very, very direct consequence of that. Therefore, and what is most important is, therefore, right to live leads to responsibility to curb pollution. You are not doing any favor to anybody by curbing pollution, neither state nor anybody else. Because you want to have the right to live, you are doing it. I'll come to you, Dr. Agnihotre, in the end. As such, I am on overtime. Affirmative environmental action leads to justice is another twist that you should understand. the interpretation of Article 21 in favor of environmental protection is concurrent with the worldview on combining pro-environmental action with the concept of justice. Please hear me very clearly. In other words, justice is not seen narrowly for only humans, but it is also seen for all living creatures too. So therefore, all over the world, including at The Hague and including all developed nations, including India, now the anthropogenic view is discarded and people are talking about two components of environmental justice. One component is obviously justice to humans. Believe me, you are living in a political world. You have to have justice given to human beings, but not at the cost of killing tigers, not at the cost of cutting trees, not at the cost of doing river linking and contaminating all the rivers equally. You have to be more responsible than that. So therefore, you have to have justice to ecosystem is a very important component of the debate. So now the justice concept is broadened now, and you will be surprised why I am talking about constitution and taking over time in the presentation. But believe me, it is directly related to what you are trying to find. Article 48A is article of the Constitution, which is the directive principle in the Constitution. Which is directive principle in the Constitution. What is directive principle? It is the order given by the honorable Constitution to the people who rule. Do I rule? I rule my students, but I also use the public exchequer. All of you pay taxes, therefore I get my salary. So I become the state by innuendo. So I am also a state. Not only director of my institute is state, but I am also state, because every rupee of my expenditure is coming from public exchequer. So the point is that Article 48A states that states shall endeavor to protect and improve the environment. Now, please try to understand English language like satin here, that there are two terms, endeavor. More important term for endeavor is protect and improve. So it is not one-time activity, it is an endeavor that we are talking about. It's a longer, prolonged, deliberate activity. And what is it? Endeavor to protect and improve. So protect and improve. Thank you. I have put so much of steam in atmosphere by talking. Okay. So you have so much of protection and improvement. That is a part of integral part of the government's order. Why do you do that? So that forests and wildlife of the country is protected. Do you hear me? It is not the gamla that my wife has put on the balcony of gulab and tulsi, but we are talking about natural ecosystem. That is what is the mandate given to the. So when state is coming hard and making arguably from industrial point of view unreasonable rules, they are helpless. That is what is their mandate, that they have to protect natural environment. That's what we need to understand and honor. But it is not the responsibility of only the state to protect environment, but it is also the responsibility of a common citizen. And mind you, the first ever fundamental duty clause in India's constitution was amended was on account of environmental degradation. We did not live up to what Baba Saheb wanted us to be. Therefore, we had to be told that this is a fundamental duty, and to protect it, it is a fundamental duty of every citizen. Verbatim, I am telling you, to protect and improve the natural environment, same language, including now, it is for the common man, dilating the principle of what is fundamental duty, including forests, lakes, rivers, and wildlife, and to have compassion for all living creatures. Never forget, you are a proud citizen of a largest democracy of the world. More importantly, you are a proud citizen of a country which is of Buddha and Ambedkar. So these are very clear terms that are embedded into the constitutional amendment, that compassion for all living creatures. So how do you do that? There is a urban habitat cycle, which is basically urban water cycle. If you only talk about, I can do the same thing for urban solid waste cycle. I can always do that. Urban other resource access cycle. Urban cycle with respect to taking resources from villages. I can develop this diagram for anything. And then you have to recognize what is the natural ecological cycle. Close the circle, number one. They are not closed today the rate at which we are consuming resources, and they need to be moved on each other. That is what we need to do. So, well, we are doing some work in constructed wetland, which is not a topic here, but I'm just saying that we are asking a very responsible question: innovation for who? And that is a very important question that an academic has to ask. I can say information for who? I can have solid waste management for developing as a theme for development of social engineering and business of justice idea, for adopting adopting circular economy approach. I can say the same thing about water and wastewater management as a theme for social engineering. I can say you can choose what you like, but the whole idea is social engineering, business for justice. Justice is not only to humans but also to ecosystem. Just so, therefore, strategies are innovation, frugal engineering, preventive environmental management, incremental development, justice for weaker among us, and prevention and preservation of ecosystem. This is my last slide. There are two constituencies that I work for. Each person has a choice, but the two constituencies that I have chosen for is this first constituency is this: girls, especially school-going girls of this country, who are neglected. We as such made a blunder of neglecting the 50% population of our country. The more important and more significant gender of the society does not have share in power, number one. They need to be given priority. And the second is, this is a Python Maharaj, which is sleeping in my constructed wetland on IIT Bombay campus. Richa worked on it. This Python Maharaj there for 3 nights and 4 days, must have eaten some hen, some fowl, some and then sleeping there for 3 nights and 4 days. Sanjay Gandhi National Park conservators came, they put a tent there, they slept there, they brought a van, they brought a very big basket, and finally when the fellow started moving, they picked him up and put it in the van and took it in a Sweetwater lake nearby. They were not able to believe that this was a wastewater treatment plant, because these animals are known for not going close to wastewater treatment plant. Now, I don't need ISO 14,000, ISO 13,000, 30,000 certification for my technology friends. It is certified by Python Maharaj. Python thinks it is clean enough to sleep there for 3 nights. So it is possible if you are innovative, if you mimic nature, we can go closer to nature, and then we can be very responsible in terms of managing the solid waste, and also weave the story of solid waste with other waste, such as wastewater, because they are two sides of the same coin. Thank you so much for being patient with me. And as always, you need to forgive a professor for going over time. Thank you.
Thank you so much, sir. I wish we could have redesigned the schedule to make it a full session, so that you could have also had more time to get into the details of all these things. So we are behind time, so we'll take a tea break for 15 European minutes. Okay, so it's not Indian 15 minutes, because that's a lot more. We have put out a small book exhibition outside. You can pick up the books if you need to. We'll give you all the books in PDFs before you leave this campus. That's a promise. But you can pick up copies, but just allow everyone to just see them before they are kind of taken away. So we are back to this room. It's 12:10 now. We're back here at 12:25 so that we can start. Thank you.